Good afternoon, everyone, and welcome to day two, part two of our hardware applications for hospital hardware Occupant virtual instructor-led training course. My name is Katie Flower, back with you today. And today's session is all about codes specific to hospital so that we can choose the appropriate hardware as well as doors and frames, but more specifically, hardware. This session is being recorded just like yesterday's. If you miss any or a part, then you can always go to the Occupant Academy virtual instructor-led training portion of the website. And on the top right-hand corner, you will find links to the recorded sessions. Review them as often as you need to or want to. Additionally, within 24 hours, you should receive an email thanking you for your attendance. Each individual course is worth 1 credit hour for continuing education, but you do need to self-report. You can use the email as your proof of attendance. If you have any questions during today's session, please feel free to use the Q&A button at the bottom. If there is any fuzziness, it's because of the bandwidth on Zoom, and there's nothing I can change or control. Hopefully everybody can see the screen clearly and can hear me clearly. But if it does get a little bit fuzzy, you may want to try to get out and come back in. Hopefully it works great for everybody. When it comes to hospital hardware and hospitals in general, they are usually, every state in the United States is governed by one version of the IBC, the International Building Code, or another. And the website www.iccsafe.org, you can look up your version of the IBC that the project state is using. There are some states like California that models their code after the IBC. They take the IBC, they modify it, and then they reprint it as the California Building Code. Some cities will use their own building code based on the IBC, but modified. You may have a city and a state code that you have to follow. Additionally, when it comes to healthcare, many times they use NFPA 101. NFPA 101 is the life safety code, and codefinder.nfpa.org can help you look up which version of NFPA 101 is in effect for your reference project state. Those are both great website resources for you to use. What I used to do when I was a specification consultant, and I did many very large projects, I would make an Excel cross-reference table for the project and keep it in my project folder and list out the code requirements for doors and hardware based on the different versions of the code that was in effect at the time of the project. And then look across the table and highlight any that were different. In this case, the width, the minimum clear width is the same all the way across, where for the movement of beds, or in other areas, it's 32 inches straight across, minimum height 80 inches. And I would build a spreadsheet so that I could have the code references handy, but also very, very clearly identify which codes conflicted with each other. Whenever you have a conflict between one or more codes or a code and a standard, the more restrictive requirement applies, unless there's some kind of written exception from the AHJ, the authority having jurisdiction. Let's talk about a couple of definitions before we get into the code requirements. We have to look at code requirements from a few different angles. But first and foremost, means of egress. The definition of means of egress is critical because our path of egress out of a building or into an area of refuge is very important to applying hardware. For example, if we have delayed egress exit devices, you can only use one in a path of egress before entering an exit. So understanding the different components and what they're called is very important in order to specify the appropriate hardware. A means of egress is defined as a continuous, unobstructed path of both vertical and horizontal egress travel from any occupied portion of a building to a public way. and it consists of 3 separate distinct parts: the exit access, the exit, and the exit discharge. The exit access is that portion of a means of egress that leads from an occupied portion of the building to an exit. This area that's shaded in gray is exit access. In most hospitals that you're going to be working with, more of the doors that you're dealing with will be exit access doorways instead of an exit door. Very similar in the way that you apply hardware and the code requirements, but there are some nuances and there are some differences. The exit is that portion of a means of egress between the exit access and the exit discharge. Exit components include exterior exit doors at the bottom, at the level of exit discharge when you're going to the outside, but exits also include interior exit stairways and ramps, exit passageways, exterior exit stairways and ramps, and horizontal exits. And you will see horizontal exits used in hospitals quite frequently. But this is a stair. The white area is an exit. Once you cross through this door into the exit, you are now protected with fire resistance partitions, floors and ceilings, and fire protection rated door assemblies, fire doors. Once you get into the exit, you should be protected for the rest of your trip out of the building. But not all people in a hospital can evacuate the building. Horizontal exits compartmentalize into fire compartments no greater than 22,500 square feet. And so when you cross through a horizontal exit, this is a fire resistance rated fire barrier. You also have the floors and ceilings that are constructed the same. You have vertical all the way through the building from one side all the way straight across. And this fire barrier protects, if this is the area of fire origin and you go through this double egress door, you are now protected on the other side. You're in a completely different fire compartment. And not all double egress doors are going to be a fire barrier. It's important to know what is the rating. If it is a 60-minute or 90-minute B-label door, then it is guaranteed it is a horizontal exit and you've got double egress doors. So this creates an area of refuge. If you've got patients that you're evacuating while they're in bed, you move them through to the other side, and now they can await the next step in either evacuating the rest of the way or waiting the firefighters to do what they need to do. In Chapter 10 of the IBC, and the references in this course are from IBC 2015. It's the most widely adopted, and they're very similar in the other editions. But the occupant load is calculated on the square footage of the area and the occupancy type. When we have 1 to 500 people, we need a minimum number of 2 exits or exit access from any particular story or portion of the building. When we have 501 to 1,000, we need 3. And more than 1,000 people, we need a minimum of 4 exits. So if you've got a high-rise hospital, 18-story, which is the one that we're modeling this class after, the openings that we will be looking at are from a hospital that is very large, and it has more than 1,000 people. It's 18 stories tall, so 4 different vertical exit stairs in order to get out of the building. A hospital is I2 in its classification. I2 is an institutional. These people are not capable of self-preservation without physical assistance from others. And the others, in this case, for a hospital, would be staff. So when you hear I2, or when you see that in the code, especially IBC, the International Building Code, that is your cue that you can either use hardware or you can't use hardware. It's going to be specific to that type of occupancy. And healthcare facilities is broken down into 2 different types: nursing homes and hospitals. There can be some assembly within an I2 hospital. Whenever you've got a dining hall or multi-purpose room, training classrooms or conference rooms, and the key benchmark is 50 or more occupants. If you've got a training classroom that can hold 50 people, that now makes that section of the hospital assembly occupancy. And if you have the same egress path, assembly occupancy will take priority over the institutional because it's more risk, it's a higher risk group, and your means of egress components, your hardware, is going to be much more restrictive. Additionally, you could have high hazard, which is a storage room. Maybe they're going to be storing med gas, but it has to be a certain quantity of med gas and how they're stored, what type of canisters, how they're stored within the storage room. But if it is classified as Group H high hazard, then your requirements are more restrictive for the hardware that you select, and exit devices would be required from any high hazard space. It could be any area within the hospital that you're storing materials that are highly flammable or likely to explode. When in doubt, always ask the question. Now we'll take a look at the basic egress requirements for hospitals based on IBC 2015. We need a minimum of 80 inches clear opening height. And typically you're going to see doors that are 7 foot tall or taller. But if you do use a 6'8" tall door, just make a mental note to yourself that door closers and door stops are permitted 78 inches minimum above the floor. It doesn't say anything specifically about surface mounted mag locks. And you see that the mag locks are hanging down into the clear opening height. These doors are 7 foot tall and they just make it with the mag lock. But it is something, a detail that you have to pay attention to, whether you're specifying the hardware, you're an architect approving submittals, or you're a detailer supplying the hardware. Make sure you look at the cut sheet for the height of that mag lock. And if you're a contractor, make sure you don't add any extra shims to set it down lower. The minimum is 78 inches above the floor to the bottom. And typically, you can't use these on a 6'8" high door. 7 foot is very close, but you can do it. The minimum clear width is 32 inches unless by exception, and this is for egress purposes. However, in I2 occupancies where there's movement of beds, any place that serves patient bedroom areas, the corridors, the stair doors, everything within that area needs to be a minimum of 41.5 inches clear width. That's why we see doors that are extra wide in hospitals. They're going to be moving patients and evacuating patients while they're still in bed. And any area that serves movement of beds must be a minimum of 41.5 inches clear width. Egress doors shall be of the pivoted or side hinge swinging type unless by exception, and there are some exceptions in healthcare. The swing direction of doors when serving 50 or more people, the door needs to swing in the direction of egress travel. This is why when you have double egress doors, the doors swing in opposite directions because our path of egress is in both directions in the corridor, and we have more than 50 people going in each direction. In Group H, high hazard, regardless of the occupant load, the door needs to swing out in the direction of egress. One exception that you're going to see a lot in healthcare and hospitals is manually operated horizontal sliding doors. This is the new right slide. It can be acoustical or non-acoustical, can be used for individual offices or any exam or patient area where you've got less than 10 people. You can have a sliding door. Encroachment. During its swing, when a door swings out onto an egress corridor, it shall not cut down the required width by more than a half, and when fully open, not project more than 7 inches into the clear opening width. Oftentimes, recessing the doors so that they can swing against a wall, that's a better option. But many times you'll see doors that swing into patient rooms instead of out of. It gets to be a little problematic when you have behavioral health care. Do you swing the doors in and risk them barricading the doors? And if they do barricade the doors, there are some hardware solutions that will help prevent that. But if you swing the door out, you need to be aware of the encroachment portion of the code. Unless by exception, all doors from the egress side shall be readily openable without a key or special knowledge or effort. When you look at the cut sheets, if it says inside grip always free, that means we have the one motion free egress and we're good to go. Hospitals do have many different exceptions though that do permit locking of the door from the egress side. And it's because in a hospital, there's different areas of detention or restraint that is for the clinical needs of the patients. And we don't need them wandering into an area that's more dangerous. We don't want them to wander into an area that's more secure and more dangerous for them. We want to keep them contained to their area. So here are some of the areas where we can lock the door on the egress side. Very, very wide open. Number one, places of detention or restraint. If you have a holding room or some kind of behavioral health area, the AHJ will allow in places of detention or restraint, and it's a very wide open for interpretation so that they can look at the area, their means of egress, the staffing, and then say yes or no. On pairs of doors, where you have the inactive leaf with automatic flush bolts, that is permitted as long as there isn't any doorknob or surface mounted hardware to make somebody feel like they could go up to that door and open it and get out. As long as there's no doorknob or surface mounted hardware, automatic flush bolts are permitted in a door, in a pair of doors, in a means of egress. Fire doors, when you have a less bottom rod exit device or an exit device after the minimum elevated temperature has disabled the unlatching mechanism in accordance with the listed fire door test procedures. So after a certain amount of time after this door heats up, this door does not have to unlatch because it's disabled. Manually operated flush bolts or surface bolts are not permitted except when you have a pair of doors serving a storage or equipment room and that room does not pose a hazard to safety of life, meaning that it's not normally occupied. You don't have a bunch of people sitting inside of a storage room, so therefore the AHJ can permit surface bolts or manually operated flush bolts on the inactive leaf. This one is specific to I2 occupancies, which is our hospitals, where a pair of doors serves a patient care room, their bedroom. The inactive leaf can have self-latching or surface mounted bolts, provided that that inactive leaf is not needed to meet egress capacity requirements, and the inactive leaf cannot have any doorknobs, panic, or similar operating hardware. It's very clear which leaf is the active leaf. The nurse is going to come and go in and out of the active leaf. When they need to open the inactive leaf, they push in on this button. When they need to close the door, they pull the door closed. The unlatching of any door or leaf shall not require more than one operation. If you have a pair of doors and an overlapping astragal, that inhibits the free use of each leaf. If I push on this exit device and that astragal stops me from getting out of this door, that is not permitted because I would have to unlatch this door in order to unlatch this door, and that's what this is saying. Only one operation to be able to get out. Exit devices are not required in I2 occupancies unless you have a mixed occupancy with some assembly. Assembly would be your dining areas, your multipurpose rooms, your training areas, and exit devices are required when both leaves are needed for exit purposes, like a double egress door. So if you need an exit device, then it needs to be at least half the width of the door. The operating portion has to be at least half the width of the door, and it has to be rated UL 10C for on a fire door or UL 305 if it's panic hardware. Special locking arrangements are electromechanical devices locking the door using electricity. And in some of these cases, in many of these cases, we are actually physically locking the egress side of the door. The first one is called controlled egress. It's relatively new in the codes. It started with the 2015 edition, I believe, and 2018 also allows it. Before that, it was something that needed proper AHJ approval. But controlled egress is actually locking the door on the egress side with a mag lock. That's the primary lock typically, because these are usually double egress doors. And this key to using delayed egress, it's electric locking systems, including electromechanical or electromagnetic locking systems, are permitted in groups I1, which is assisted living, and I2 are hospitals, where the clinical needs of persons receiving care require their containment. Memory care units, infant protection systems, behavioral health, Alzheimer's wards. These are all examples of where the clinical needs of the persons receiving care require their containment. It goes on to say that controlled egress doors shall be permitted in occupancies where the building is equipped with an automatic sprinkler system or an automatic smoke or heat detection system. And all hospitals, all I2 new construction by IBC requirements must be fully sprinklered anyway. And all of the following criteria must be met. So you have the card reader that will unlock the door in the path of egress. You notice there's no motion sensor, there's no extra push button on the wall. We are physically locking this door on the egress side. And because it is a double egress cross corridor pair, both directions happen to be locked with a mag lock. That's an actual controlled egress. And so again, the requirements are a fail-safe lock tied into the fire alarm system on actuation of the fire or smoke detection system will drop power, and all clinical staff must carry the key or credential. In this case, it would be the badge. There are some exceptions to this. Items 1 through 4 do not apply because of the clinical needs of the patients, require their restraint or containment as part of a psychiatric treatment area. So if you're in a behavioral health area, you don't need to use a fail-safe lock and you don't need to tie it into the fire alarm system. Also, items 1 through 4 shall not apply where it's part of a child abduction or infant abduction system as part of a nursery and obstetric area as part of an I2 hospital. Again, items 1 through 4 doesn't have to be fail-safe. It doesn't have to tie into the fire alarm system. So you are actually locking the door on the egress side. All clinical staff must carry a key or credential. There's a life safety plan posted at the nurse's station, and the AHJ has given approval to that life safety plan. Where these are most commonly used within a hospital, I mentioned some of these already, the behavioral health area, your dementia units, memory care units, infant patient wings, maternity wing, emergency care unit, and MRI equipment area to make sure that somebody doesn't accidentally get into an area they shouldn't be. The components of controlled egress primarily will be a mag lock. It is fail-safe right out of the box, or you could use a fail-safe electromechanical lock. If you meet the criteria for the exceptions, then you could use a fail-secure electromechanical lock and not tie it into the fire alarm system. The other way that we control doors from the egress side are with delayed egress. Delayed egress has been around since 1981 and has changed only slightly through the years. You can have either the self-contained delayed egress system where you're using the mag lock and everything is self-contained, or you can have it built into the exit device bar. If you want to get out of this opening without setting off the alarm, the card reader allows you to shut the system down for momentarily to get through the door and not set off the alarm. Delayed egress are permitted anywhere except for Group A, which is assembly, Group E, educational, and H, high hazard. If you have assembly mixed in with your hospital, your egress path, you've got to make sure to check it and don't use delayed egress along that egress path for these when you have assembly mixed in. But in I2, in a hospital, if you don't have a mixed occupancy, you are able to use them as long as you meet all of the following criteria, which will be you push on the exit device and there's a nuisance delay of up to 3 seconds. Once you hit that, an alarm will sound at the opening, and in 15 seconds, the door can be open. If there is a fire, then it will immediately cut power to the delayed egress system and allow you to exit. It can be 30 seconds on exception, and that's mainly in behavioral health. The most common applications for delayed egress in hospitals will be in areas to restrict public access. Because it's not for the clinical needs of the patients, we can't use controlled egress, but to restrict public, you can use delayed egress. Anywhere that controlled egress is not permitted is a good candidate for delayed egress. But you can only use one delayed egress on a path of egress before you enter and exit, unless by exception. Our most common components for delayed egress are a built-in mag lock with everything built in, or delayed egress exit device with everything built in. There is a key switch usually for resetting the system. Somebody has to go to the opening and actually check to see what happened before they reset the system. And that's where a key switch for manual reset would be involved. Typically they come with the device, but if they don't, you can specify it separately. And sometimes you may need a touch sense bar to initiate the delay if you're using internal or external self-contained unit. Stairway doors. If it's a low-rise building, which is defined as 75 feet or lower above fireman vehicle access, the doors are permitted to be locked on the ingress side of the stair, provided that they're openable from the egress side and capable of being unlocked simultaneously without unlatching on a signal from the fire command center or a signal from emergency personnel from a single point inside the main entry of the building. So if I do lock the stair doors, they need to be electromechanical fail-safe so they can unlock under any condition simultaneously and permit re-entry. If it's a high-rise building, the addition is every 5th floor, you have a two-way communication system that is to a constantly attended station. And you can call and say, hey, I need to be let in on floor 16, and they can push a button and let you in. The hardware requirements are exactly the same. Fail-safe, positive latching, because it is a fire-rated opening. Now let's look at some hardware specific just to I2 occupancies. In Chapter 4 of the IBC, and a lot of people overlook this, so I want to make sure you know where this is found. In Chapter 4, there are special detailed requirements based on use and occupancy. And healthcare, I2, gets their own section, Section 407. Let's take a look at a hospital, a typical floor plan. Because it's so large, it's broken into 3 parts. And somewhere on the page, you will see a plan legend. I like to highlight my smoke partitions, fire barriers, and fire and smoke barriers. In this case, the pink is non-rated smoke partition. So any doors there will be non-fire rated. 1 hour fire barrier and 1 hour fire smoke barrier differ from the incidental use table, I can determine what my doors and hardware would need to be for ratings there. And then the exits, I've highlighted those in orange. And I'm looking to see if there's continuity to make sure that any storage room that's over 100 square feet has a 1 hour resistance rated partition with a 45-minute door. My stair exits are 90 minutes with 2-hour walls. My horizontal exits are 2 hours. The patient rooms are on a regular corridor smoke partition, non-rated. Here is a horizontal exit that is 2-hour fire barrier with 90-minute cross-corridor double egress doors. And then I can pan out and take a look at the overall plan and say, yes, I see the continuity. Those doors are rated. Here's where the section is compared to the other two that are on the same floor. Orange is an exit. Green is my smoke barrier, which is going to compartmentalize into 2 smoke compartments. And that is a pair of cross corridor 20-minute rated doors because it's a 1 hour partition. This is not a horizontal exit. This is a smoke barrier. I can apply my hardware accordingly. And the terminology can get confusing. So that's why I draw the highlights on the plans. Sometimes you'll see them on a life safety plan, which is good. But if you're detailing this or if you're trying to write a specification, it's much easier to visualize and see, okay, every clean workroom in this building is a 45-minute rated door. And if it's not, it's a red flag. It's very easy to spot and easy to ask the architect to confirm. And if you're an architect, it's very easy for you to see and visualize continuity. Here's the last part of the building, which shows the horizontal and vertical exit, my other fire barriers and smoke partitions, and I can visually confirm that the doors within those have the correct rating or not. The definition of a smoke partition is a continuous membrane designed to form a barrier to limit the transfer of smoke. A smoke partition does not carry any fire resistance rating. It is intended to provide much less protection than a smoke barrier, and it's not required to be continuous through the concealed spaces and through the ceiling. The use of smoke partitions is limited to healthcare hospital occupancies for corridor walls that do not need a fire protection rating, but they do need to limit the transfer of smoke. Oftentimes you'll see them for on-call rooms or patient bedrooms, but if it's a smoke partition, that door does not need a fire rating. Your patient sleeping rooms, treatment rooms, and on-call rooms will be smoke partitions. Louvers are not permitted because smoke will travel faster. The louver blades will not be able to close quick enough. If they're not heated up by fire, the fusible link will never close and the smoke will come in and harm somebody while they're still in bed. The doors do need to meet smoke and draft control, which is UL 1784. There should be an S label on the door to indicate that you need just like the PEMCO S88 smoke seal. Corridor doors are not required to have a closing device, but they must be positive latching. Roller latches are not permitted. So even though these are non-fire rated doors, they do need to have a positive latch because they're in a smoke partition, but they do not need a door closer. This is the incidental use table in Chapter 5 of the IBC. Table 509 lists the fire ratings for the walls. You would have to go to Chapter 7 to look up the corresponding door fire rating. I'll just mention it as we scroll through. Some of these towards the top are less common, but if you have furnace rooms or boiler rooms with large equipment, refrigerant machinery rooms, hydrogen fuel gas storage rooms that are not high hazard, your fire protection and separation rating is here on the right-hand side. But if we scroll through, we will see there are some that are very specific just to I2 occupancies, which is our hospitals. In group I2 occupancies, laboratories that are not classified as high hazard, we need 1 hour fire resistance rated walls and automatic sprinkler system. This would be a 45-minute rated door if we look up in table 716 in chapter 7 of the IBC. For I2 laundry rooms over 100 square feet, 1 hour fire resistance rated walls with 45-minute rated doors. If you have an I2 patient room equipped with padded surfaces, 1 hour wall, 45-minute rated door. I2 physical plant maintenance shops are going to be 1 hour protection with 45-minute rated doors. In ambulatory care facilities or I2 hospitals, waste and linen collection rooms with containers that have an aggregate volume of 10 cubic feet or greater, 1 hour wall, 45-minute door. This is why you will almost always see soiled utility, clean linen, soiled linen rooms with 1 hour walls and 45-minute rated doors. This is exactly where it comes from. And group I2 occupancy storage rooms that are greater than 100 square feet. That's just a 10-foot by 10-foot room. Often in a hospital, you're going to have a very large storage room, larger than that. That's a 1 hour fire resistance rated wall and 45-minute rated door. So this is where you find it, table 509 in the IBC, the incidental use area. So doors and corridor walls that are soiled and clean linen, soiled and clean workrooms and storage areas, you would refer to table 509, the incidental use area, and most commonly those doors will be 45-minute rated and must comply with NFPA 80, the standard for fire doors and hardware, which means steel anti-friction bearing hinges or continuous hinges or pivots, positive latching, self-closing, and any accessories that are on this door must be listed or labeled as well. Smoke barriers are a continuous membrane, either vertical or horizontal, such as a wall, floor, or ceiling assembly that is designed and constructed to restrict the movement of smoke. Smoke barriers are used to form smoke compartments, and in healthcare specifically, these smoke compartments are used to relocate people safely and promptly during a fire. They will have a 1 hour fire resistance rating. This green line is a smoke barrier. Our smoke compartments, just like our fire compartments, can be no larger than 22,500 square feet. If I am evacuating patients from this side, I cross through into this door or through this smoke barrier, I can now get to a horizontal exit and an area of refuge. The doors and smoke barriers in I2, and these are your cross corridor doors, opposite swinging doors are installed across a corridor. The door shall not be required to be protected in accordance with section 716. That is critical because this is a 1 hour wall with a 20-minute door. And what this is saying is that door does not need to be 20-minute rated. And the reason they're saying that is because for years, the code would say positive latching devices are not required. But then door manufacturers would say, well, you're ordering a 20-minute door and you're telling me not to prep it for any hardware because you're not putting any exit device on it. I need proof. I have to have an exit device or some kind of latching hardware to pass a 20-minute fire test. And there was a battle back and forth. The code would permit it, but no manufacturer could make it. Now they're saying the doors don't have to have a fire rating if they're in a smoke barrier and they're double egress doors. This way they don't have to be positive latching. They still need to be self-closing, and they would need smoke and draft control, but they wouldn't need to be positive latching in this instance. And the instance is smoke barrier, cross-quarter doors. Any other door in a smoke barrier would still be 20-minute rated, but these doors are saying that they don't have to be. Now, if the architect makes them 20-minute rated, like this one did, then you treat it just like any other 20-minute door. Unless the door manufacturer has a label that they can put on that door without positive latching, then you would have to supply exit devices. Sliding doors, doors within care suites can be manually operated horizontal sliding doors. They can be either automatic like this, or if it's an ICU, they're just manual sliding doors. You see them all throughout different sections, but with doors that are within a care suite, they don't need to be smoke tight because the compartment itself is smoke tight. And that's where you're going to start to see a lot of the sliding doors, like a BSIM sliding door. And I'm going to open it up to any questions. Do we have any code questions for hospital specifically? While I'm waiting to see if anybody has any questions, I do also want to add, in addition to the IBC and NFPA 101, a lot of healthcare facilities, in order to get state and government funding for Medicare and Medicaid, they may have some more restrictive, the Joint Commissions may have more restrictive requirements. You also have to take into consideration whatever your local Joint Commission requires on a healthcare project. I don't see any questions yet. I'll wait around for a few more minutes. If we don't have any questions, that's fine. Just remember that you can review this or any of the sessions if you happen to miss. If you haven't signed up for the other classes, this is an 8-part series. Tomorrow, we're going to start taking a look at specific hardware for 3 different door opening types. Will I speak more to labeled protective plates later? Yes, when I get to specific openings, I will, but I'll go ahead and mention it now. Any protection plate that is 16 inches or lower on the bottom 16 inches of the door does not need to be labeled. Any protection plate that is higher than 16 inches, an armor plate, would need to be labeled unless it's installed at the factory. But I will be mentioning it again when we look at specific openings. Good question. Tomorrow through the rest of the class, we'll be taking a look at specific openings, common openings, in-swing patient restroom doors with rescue hardware. We've got some lead line doors we're going to take a look at, cross-quarter controlled egress doors, pairs of doors with automatic operators. And again, as we go through and progress, if there's any type of opening that we haven't covered, please feel free to send me an email. That last class, we will review a bunch of other openings that we haven't covered yet. And there may be something that you specifically would like information on. Please make sure to send me a note. But if there are no other questions, I want to thank you for being here today. Look forward to seeing you again tomorrow. Reminder that tomorrow's session is in the morning. It's not in the afternoon. So we'll see you in the morning tomorrow. And thank you. Have a great afternoon.